All right, good morning. Sorry I'm a minute late. My Wi-Fi was having problems, and that's not the first time this has happened during this event, and I'm sure it's not going to be the last. The joys. All right, so we are going to pick up where we left off last time. So we finished 3.3 and 3.4 last time, so we're going to work on 3.5 as well as 3.6, and we'll see how many we can knock out in 3.6. Maybe we can finish the section, maybe not. And before we do this, let's do, actually, I'll just use this. As a reminder, the rules for adding signed numbers. If they have the same sign, you add the numbers and you keep the sign. If they have different numbers, different signs, you will subtract the numbers larger minus smaller. And remember, I'm saying an absolute there. You're ignoring any pluses or minuses. You just take the bigger looking number minus the smaller looking number, and then keep the larger numbers sign, which the abbreviations for those were SAK and DSL. If you like abbreviations, they can be very helpful. Then we said, all right, well, that was adding numbers. To subtract signed numbers, we never really do this. We change it to addition. We change the sign after the subtraction, and then follow the previous rules. So you get a 2-for-1 basically. SAK and DSL are the rules for adding and subtracting signed numbers, but asterisks, we don't actually use those rules for subtracting them. We turn a subtraction problem into adding a negative, or for subtracting a negative, we turn it into adding a positive. Then we use those two rules. We did lots of examples of those last time, so I don't want to really do any refreshers there. We need to move on to multiplying signed numbers. And I will go ahead and warn us that kind of the same thing that we had with subtracting, how it kind of fell back on the addition. Well, that's exactly what happens with division, except their rules are just going to be the same. So when multiplying, spoilers, or dividing two signed numbers, the product or quotient of two numbers with the same sign is positive, and the product of two numbers with different or opposite signs is negative. And just as a reminder, if you multiply 0 by anything, it doesn't even matter what the sign of the other number is. 0 times anything is 0. But these are the two main rules. And they use the word different signs here, but I'm going to change that to opposite signs just for emphasis. So my version of the rules, the product, and let me not use their full words. I was trying to do that and I'm not going to. I didn't want to. My version for multiplication. That's what I wanted to say. Same sign. The answer is positive. They have opposite signs. The answer is negative. And that's it. Same sign, positive, opposite signs, negative. Now I give these abbreviations. Same sign, answer is positive. Those important words are the same sign and that the answer is positive. So let's take the abbreviations for those, S and P. And then for the other one, if we have opposite signs, same word is different, but I like the word opposite for a reason, then they are negative. So that would be ON, opposite negative. Same positive, opposite negative. Now this is only dealing with two numbers at a time. We never think about multiplying 3 or 4 or 5 numbers at a time at our level. We did 2, then the next one, then the next one, then the next one. So SP and ON, and what some people will actually do, per my suggestion, is combine these and say it's SPON, spawn, kind of like spoon, but with a O missing. If the signs are the same, the answer is positive. If the signs are opposite, the answer is negative. And that is for multiplication. And again, spoilers, is also for division. So later you're going to see me just kind of copy paste this. All right, so spawn, S-P-O-N, not S-P-A-W-N. Same, positive, opposite, negative. So what you have to do is make sure you're keeping your rules straight. There are rules for addition and subtraction, and then there are completely different rules for multiplication and division. If you use the addition rules on a multiplication, you're going to have a bad time. If you use the multiplication rules on an addition, you're going to have a bad time. So please make sure you are paying attention, you know which rules apply to which, and you're taking your time. All right, so let's knock out some of these. We're not going to do all 6 of these. 4 times negative 13. Let me pull my annotate on. Okay, so all we're really worrying about here is the product of 4 and 13 first. And if we do 4 times 13, that's going to end up being 52. 13, 26, 39, 52, going up in 13s. But we have a positive 4 and a negative 13. Those are opposite signs, so the answer should be negative. So that should be a negative 52. That's it. You don't have to worry about which one's bigger, which one's smaller. It doesn't matter for multiplication, just for addition and subtraction. Next up, we got 7 times negative 25. I wish I'd give myself a little more room. Hold on. Oops. There we go. All right, so that was negative 52. Negative 7 times 25. So let's not worry about the signs yet. Let's just take 7 times 25, which would be 175. Remember, you should be not using calculators for problems for the first half of chapter 3, technically speaking. All right, but then we have a negative times a positive. Those are opposites, so the answer should be negative. So that's a negative 175. Next up, we got 9 times 18. And a lot of you might not even think about the rules here. You might just say, oh, 9 times 18, if you do your math, that's 162. Write that vertically if you have to. We have a positive 9 and a positive 18. Those are the same sign, so the answer should be positive. Same sign, positive. So it is a positive 162. D, 0 times anything is 0. That's easy. Don't even have to think about the signs. E, I'll do E, but I'm going to skip F. F, don't forget to account for the decimal places. So you have 1 decimal here, 1 decimal here, which means there'd be 2 in the answer. And then you're basically doing 85 times 36. But with E, we got a 9 in the top and an 18 in the bottom. We can reduce these since it's multiplying fractions. 9 goes into 9 once and into 18 twice. We got a 5 and a 10 that we can reduce. I'll switch colors to show that. 5 will go into 5 once and into 10 twice. Remember, I don't care if you have to write these as prime factors and then reduce, but it is easiest to reduce first before multiplying. So this is just negative 1 over 2 times negative 1 over 2. Now we multiply straight across. There's no LCDs with multiplying fractions. Make sure you have your rules straight. All that stuff from chapter 1, as I said in class, never goes away. In the top, 1 times 1 is 1. In the bottom, 2 times 2 is 4. Now we account for the signs. So that's a negative and that's a negative. Negative are the same sign. So the answer should be positive, SP. So that should be a positive 1/4. So I'm not going to show the work for this. But if you do 8.5 times 3.6, you'd get 30.6. I'll leave that up to you to show. A negative times a negative is a positive. So you should be able to get 30.6 on your own for that one. All right. So I got to clear my screen. Give you about 10 more seconds. Okay. I'm not going to do A or B. I just want to mention that the word times and product both mean multiply. So this is 4.5 times negative 5.2. This is negative 3 times negative 19. There's nothing really anything crazy going on there. So let's get into multiplying several bits of negatives and or positives. And this is something that you don't have to know. It is optional, but it will make things a lot shorter in the end. So I mentioned earlier that you're supposed to just do 2 at a time, but you can at least go ahead and get rid of your negatives or just have one single negative as long as it's one big product like all of these problems. And we're not going to do all of these. Let's do A, B, and E. No, not E. Let's do D. Because E is easy. E is 0 because it's doing 0 times a bunch of stuff. So they say, and again, these rules are optional. You can just do 2 at a time. 2 times negative 6 is negative 12. Then negative 12 times 3 is negative 36. Then negative 36 times negative 1 would be positive 36. Or you can just say, all right, when you got one big chain of multiplications, if there are an even number of negatives, then the answer is positive. That's because 2 wrongs make a right with multiplication and division, as they like to say. Every pair of negatives will cancel each other out because when you multiply 2 things at the same sign, they become positive. So 2 negatives make a positive, no matter the order they're in. But if you have an odd number of negatives, that means the answer is going to be negative. Let's say you had 3 of them. So 2 of them would cancel and make a positive. You've still got the third. If you had 5 of them, 2 would make a positive. The next 2 would make a positive. But that 5th one would still make the whole thing negative. Hold on a second. I got a cough and I don't want to blow your ears out. All right, glad I have a mute button. Okay, so let's see. For A, we have positive, negative, positive, negative. There's 2 negatives. That's even. So the answer should be positive. So all we really got to worry about is the 2 times the 6 times the 3 times the 1. 2 times 6 is 12. 12 times 3 is 36. 36 times 1 is 36. It's just a shortcut. With B, we got 1, 2, 3 of these, which is an odd number. So the answer should be negative. So I can just go ahead and put the negative in the answer. 10 times 4 is 40. 40 times 7 is 280. So the answer would be negative 280. I'll leave you to try out C on your own. You should get the answer of 108. Right? Yes. Oh, I didn't leave myself enough room here. That's okay. I can squish this in. For D, the last one we'll do. We got 1, 2, 3, 4, 5 negatives. 5 is odd, so the answer should be negative. So there's definitely a negative in the answer. 1 times 2 is 2, times 8 is 16, times 3 is 48, times 2 is 96. So negative 96 would be our answer. We said the answer to E is 0. If we try out F, that answer should end up being negative, what's that, 144, right? Yes. All right. Can I get this all in one? All right. Kind of going with that theme, let's talk about exponents with sign numbers. This is one of the #1 issues besides fractions, math with fractions in general, that students moving forward just completely disregard techniques, do whatever they want to do and get the answer wrong more than half the time. And what's interesting is you should actually be getting the answer right more than half the time based on how this stuff works. But people just tend to do this wrong more than they do it right. It's kind of funny. It's not really a flipping a coin situation. So you have to understand which scenario you're in. So what am I talking about? It all has to do with whether you have a negative inside a parentheses with the exponent, or if just it has a negative and an exponent in no parentheses. These are two very different things. The way that these are worked out is two completely different ways. When you have this negative inside of a parentheses, the negative gets repeated. But if you don't have the negative inside of the parentheses, then the negative does not get repeated. It has to do with the hierarchy of order of operations. An exponent comes before. This is counting as a subtraction, arguably. So you have to do the 2 to the 6th, then account for, again, I'm doing some air quotes right now, the subtraction, which is really just making the thing negative. Subtractions and negatives go hand in hand. But that's how the order of operations turns it basically into this thing right here. You do the 2 to the 6th, then slap a negative in front of the whole thing. So they don't show you that version of the answer, but negative 2 to the 6th would just have that negative a single time, and then you're doing a bunch of 2's. How many 2's? 6 of them specifically. So again, this negative did not get repeated. Now, when you repeat it, there's 1, 2, 3, 4, 5, 6 negatives, which is even. And that's why this answer is positive. An even number of negatives leads to a positive answer. So that's where this positive 64 comes from. But in this one, the 2 times the 2 is still 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So the product of the 2's is still 64, but there's only a single negative, which means there's an odd number of negatives, so the answer has to be negative. So that's a negative 64. Two very different answers. They're opposites of each other. So what I see so many students do is this top one, they'll say it's negative 64, and the bottom one, they'll say it's positive 64. Statistically, you should have gotten one right by flipping a coin, but most students will end up getting both wrong because just for some reason, people always get this backwards. When they don't practice it, when they don't say it, when they don't write it, when they don't apply it 10, 20, 30, 40, 50 times, however many times they have to do. Remember, just because you complete the homework doesn't mean you've mastered things. Sometimes you have to do the homework multiple times. Sometimes you need to go to the internet and find more examples. Sometimes you need to go back to your workbook and do the problems again. All right, I think I could squish all this in here. So for A, that's negative 2 to the 5th. Because that's in a parentheses, the negative does get repeated. So there should be 5 of these negative 2's. There are 1, 2, 3, 4, 5 of these negatives, which is odd, so the answer should be negative, using that rule from before. So the answer is a negative something. And we actually did 2 to the 5th by doing 2 to the 6th. It was 32, because 32 times 2 is 64. So that answer is negative 32. For B, with the negative 2 to the 5th without a parentheses, that negative is not repeated, so that's just a negative once, and then 2, 2, 2, 2, 2. Now here's what's interesting. In the example we did up here, we got different answers. We got positive and negative 64 because this one had an even number of negatives. The second example had an odd number. This one, there's only one single negative, which is odd, so the answer should be negative. And then we're still doing 2 to the 5th, which is 32. We get the same answer when the exponent's odd. It's kind of interesting. But if the exponent's even, we'll get different answers. Now, some students like to memorize that fact to make things a little quicker, and that's cool. But you got to be careful. If you're going to memorize things, you better make sure you're memorizing them right. I wouldn't really try memorizing that until I've done this 30, 40 times. C, the negative's inside the parentheses, so the negative does get repeated. That's negative 5 over 6 times negative 5 over 6. That is a 6 in the bottom, not a 0. Go. There's 1, 2 negatives, which is even. So the answer should be positive. And we multiply straight across because none of this reduces. 5 times 5 is 25 in the top. 6 times 6 is 36 in the bottom. Remember, no LCDs for multiplying or dividing. D, negative 5 squared. That negative does not get repeated, and negative 5 times positive 5 is negative 25 because there's a single negative. It should be negative. Very, very important concept moving forward. This is something you're going to see in your next math class, whether you're going to the next set of developmentals or QR. If you eventually get to pre-calc, this ain't ever going away. I can promise that, very much so. Okay, so I gotta clear my screen. Let's scroll down. There's a bunch more of these. We're not gonna do all of those, except for G. We will do G, because this one's interesting. We'll do this one and move on. The reason this one's interesting is because there's a negative outside and a negative inside. So we're going to have to account for both of those things. The negative inside gets repeated. The negative outside, let me just make sure you understand this is different, is not repeated. So I'm going to do this in different colors, actually. Let me represent this outer negative as a blue one, just so we can keep track of things. So that's the negative that does not get repeated. Then we have our negative 4 times negative 4 times negative 4. Now, the 3 gave us the 3 different negative 4s, negative 4, negative 4, negative 4. But that extra negative outside means there's a total of 1, 2, 3, 4 negatives, which is even, so the answer is positive. 4 times 4 is 16, 16 times 4 is 64. So positive 64 is the answer. Now, what you might think is, oh, these two negatives cancel each other out. Please do not think that way. You cannot cancel a negative outside and inside of parentheses. This is like a wall. This is a barrier. They can't talk to each other because of the exponent. So please be careful with that. All right. Okay. Dividing sign numbers. There we go. Same rules as before. So let me just copy paste what I had earlier. And change the word multiplication to division. Notice these are the exact rules as before. So I can say these are my rules for multiplication and division. SPON, same sign, the answer is positive, opposite sign, the answer is negative. Again, the rules for multiplication and division are literally the same. Back in the previous two sections, addition and subtraction, they used the same set of rules, but you had to do something to the subtraction first. You had to turn the subtraction into an addition of the opposite sign number after the original subtraction. You don't have to do that here. It's just same exact rules. It's easier. SPON, SPON, same sign, answer's positive, opposite sign, answer's negative. So we got SAC and DSL for addition and subtraction. But remember, subtraction, you have to do that change first. And we have SPON to combine the two rules for multiplication and division. SP, same positive, ON, opposite negative. Do I care if you're using my abbreviations? No. I care that if you think they'll be helpful, that you try them out, because I know lots of students that have appreciated them. But some people learn this without abbreviations, and that's fine too. All right, so let's try out these. We might skip one or two. So A, where'd my marker go? There we go. Negative 45 divided by negative 3. Let's ignore the signs for now. Let's just say 45 divided by 3. Well, 3 will go into 45 15 times. Show the long division if you have to. Show the reduction if you have to. Whatever you have to do. Now we have two negatives. Two wrongs make a right, as we like to say for multiplication and division. They are the same sign, so the answer is positive. SP. 0 divided by anything. This is another one of those rules that people start flipping coins in their heads and get them wrong, unfortunately, more than half the time, I feel like. 0 divided by anything is 0. So it doesn't matter what sign any of this stuff is, the answer is 0. 80 divided by 5, well, 5 is going to go into 80 20 times. Then we're going to account for the negatives. Why did I say 20? Sorry about that. I was thinking about another number in my head. That's not 20. Oops. I can't undo a clear. All right, I'll put the answers back. Sorry about that. 15 was the first one. 0 was the second one because 0 divided by anything, 0. 80 divided by 5 is not 20, is it? It's 16. Okay, but we have a positive and a negative. Those are different signs or opposite signs, so the answer should be negative. So negative 16. D. Uh-oh, we got a division with a fraction, so we got to multiply by the reciprocal. It's something we may not have done in a bit. So that's negative 3/4 times 8 over 15. Remember, that means we change to multiplication and flip the fraction after the division. Now it's a multiplication. We can do some reduction. Let me pull out a different color. 3 will go into 3 once and into 15 5 times. 4 will go into 4 once and into 8 twice. So that's negative 1 over 1 times 2 over 5. If you need to rewrite it, you can. You might not have to. That's up to you. 1 times 2 is 2. 1 times 5 is 5. So ignoring the signs, the product's 2/5. But we have a negative and a positive. Those are opposite signs. So the answer should be negative. ON. So negative 2/5 is our solution. E is another one that people will get wrong more than half the time, unfortunately. Anything divided by 0 is undefined. Remember, 0 is the one and only one number we can't divide by. Doesn't matter what the signs are. Doesn't exist. It's undefined. All right, I lied. We will do all of these. This will be good practice. Negative 0.84 divided by negative 0.6. Well, that's long division with decimals. It might make it easier on you. So that means, and let's ignore the negatives for now. So that's just a 0.6 on the left and a 0.84 on the right. But we can't do this division because we can't have a decimal on the left. So this is where we said, okay, we're going to move this decimal right to make it whole, however many times we have to, which will be once. Then we do the same thing to the other one. So the same equivalent division would be 6 going into 8.4. Make sure you line up your decimals vertically. 6 will go into 8 one time. 1 times 6 is 6. Subtract and you get 2. Bring down the 4. 6 will go into 24 4 times. 4 times 6 is 24. Sorry, I'm having to squish this in. Subtract and you'll get 0. So the answer is 1.4, ignoring the signs. But now we got to account for the signs. That's a negative and a negative. They're the same sign, so the answer should be positive. All right, let's move on to a word problem. Give you another 10 seconds and then I'll clear my screen. Remember, if I clear a screen too quickly, you can always go back to the YouTube videos. The links are in Canvas. They are placed every day within 30 minutes at most, because it just takes time to convert the video and upload everything to YouTube. So you might actually, I generally have the links live within 10 or 15 minutes, but then YouTube takes a little while to crank the video out. Hold on a second. Alrighty, now let's clear. And scroll down, there we go. The change in temperature in Las Vegas between 11 a.m. and p.m., so over a 12-hour period. They have an extra the. The change in temperature in Las Vegas between these two times was, silly textbook writers. Not like I wouldn't make a mistake ever in my life. Was negative 36 degrees Fahrenheit. I didn't just say negative 36. I didn't just say negative 36 degrees. I said negative 36 degrees Fahrenheit, because if it was Celsius, that would be a lot more critical of a change. So between 11 a.m. and 11 p.m., that's 12 hours that go by. And they want to know, what was the average change of temperature per hour? So temperature change per hour. So we need to take the temperature. They're telling us what to do, because the word per always means divide. So we take the temperature, the word per means divide, and then divide it by the number of hours that have happened. Sorry about that. Didn't have time to mute. So the temperature change was negative 36 degrees. I'll skip the symbols for the math part. Then divided by the number of hours that went by was 12. Well, 12 will go into 36 evenly. We'll go on 3 times. We have a negative and a positive. Those are opposite signs, so the answer should be negative. So negative 3, and then don't forget our symbol, negative 3 degrees Fahrenheit, and that's per hour. So the average temperature drop per hour is negative 3 degrees Fahrenheit. Now, they didn't tell us what it started at. They didn't tell us what it ended at. All they told us was the change. So maybe it was 10 degrees at 11 a.m. and then it was negative 26 degrees at 11 p.m. I honestly think that they meant to have the AM and PM swapped here, because in Las Vegas, being around a desert, there's not a lot of surroundings. You see drastic temperature drops like this overnight, not during the daytime. I really think these are supposed to be swapped, but it doesn't really matter for the context of the problem. Number 9, we're going to skip number 8. We're going to go to number 9 because this one, I'll show you the work. 51 inches in 3 years, average change. You're just doing, and it's decreased. So that's negative 51 divided by 3, which should be negative 17 inches per year. Just showing that very, very quickly. A slash also means per, by the way. I need to turn my volume down. That was very loud. Okay. So I need to clear, scroll down. Last problem of the section, number 9. Edward has a balance of $5,298 in his account, lucky Edward, and he bought 2 TV sets for $1,984. Find Edward's new balance. Now, there is a couple of words missing in this instruction, in my opinion. He bought 2 TV sets for $1,984 each. This is a word that is really supposed to be in this problem. Otherwise, I would just interpret this as subtracting the $5,298 and the $1,984. But what they're saying is that each of these TVs cost $1,984. So there's 2 of these. So we're going to subtract however much we pay in TVs from our original balance. So we take the balance minus the cost of the TVs. But it's not just 1 TV, it's 2. And our balance was the $5,293. And then the cost of the TVs, well, that's 2 times 1984. Now you could subtract 1984 twice, that would work as well. But I wanted this to be a multiplication problem. So the 2 times 1984 is going to be 3968. So it's 5293 minus 3968. Now, I can consider this two different ways to get this, what I just got. I can think of just multiplying the 2 and the 1984 to get the 3968 and bring the negative down. So again, I can think of it this way, just multiplying the whole numbers and then bringing the subtraction down, or $5,293 minus 2 times 1984, or we can count the subtraction as a negative because they really are the same and say this is a negative 2 times positive 1984. That's opposite, so the answer is negative. So we leave the 5293 in front. The 2 times 1984 is still 3968, but it's negative, so we still get a negative sign there. The same thing. And then 5293 minus 3968, you could change this to adding a negative if you want. Honestly, I think most of us would not. I just transpose some numbers because I'm trying to talk and write and think at two different speeds. 3968. I honestly wouldn't even do that. I would just say, oh, well, that's a bigger number minus a smaller number, so let's just go and do the straight subtraction. 13 minus 8 is 5. That's 8 minus 6, which is 2. 52 minus 39 is going to be 13. So 1325. So that says he's got $1,325 left in his account. And there we go. So this problem right here is going to segue us into the next section where we start throwing addition, subtraction, multiplication, division, exponents, and parentheses all at you at once, but now with sign numbers. And order of operations is nothing new. I have said PEMDAS about 500 times in this class already. All right, so that closes out 3.5. $3.6. Let me not annotate yet because I'm gonna want to scroll down. Order of operations. This is the third section we've had with this title. We had one of these in chapter 1, we had one in chapter 2, now we got one in chapter 3. And when we did chapter 1, I even mentioned that was going to happen. So let's see, we have step 1, parentheses. Oops, undo. I don't know how to undo that because I wasn't on annotate. It doesn't matter. That says parentheses. Maybe if I hit undo here. Yep, that works. Okay. So parentheses, exponents, then multiplication and division from left to right, then addition or subtraction from left to right. Remember, PEMDAS may have 6 words, but it's only 4 steps. Because multiplication and division are really the same thing. They're kind of opposites of each other, but they're still the same classification. Addition and subtraction are basically the same thing. They follow all the same sign rules. They're opposites of each other. So that's why we do them in that order from left to right. So if you see a subtraction, then an addition, you do the subtraction before the addition. So there's like 15 problems in this section. We're definitely not doing all of them. Let's scroll down to show some. All right, now let's put the annotate on. So I'm going to put PEMDAS up here in different colors representing the order of the steps. So P is parentheses, E is exponents. Then we'll do M and D together from left to right. Then we'll do A and S from left to right. So there's 4 steps in that order. That's the first step. That's the second step. Then the third step. And the fourth step. All right, so for A, well, we got a parentheses. So let's focus our attention inside of here. I'm going to erase that in just a second. But let's just ignore everything else. Just look at the 7 minus the 16. Okay, so let's bring the -2 plus the 5 down. But we can't do 7 minus 16 off the cuff. Again, you might be able to, but we're supposed to do the rewrite. And again, I'll never do this rewrite in a class after this, as will most of your math teachers. But we change the subtraction to adding a negative, because we just kind of get it ingrained in you that this counts as adding a negative when you see it that way. So 7 is positive, 16 is negative. So those are different signs. So DSL, because we're under addition and subtraction. So this is not ON, this is DSL. So we're doing 16 minus 7, which is 9. But the larger number is negative, so it should be a -9. That's -2 plus 5, parentheses, -9. Now this implies multiplication. If you just see two numbers next to each other without a symbol, and there's a parentheses there, that implies multiplication. Okay, so the parentheses are all gone. Oh, but there's a parentheses here. It doesn't count. Remember, it only counts if there's stuff to do inside of it. -9, that's not stuff to do. So the parentheses are done. Next up, we have our exponents. Well, there are none. So next up are the multiplication and division. So many people would do the -2 plus 5 and get 3, and that's wrong. You're not doing that. PEMDAS, PEMDAS, PEMDAS. We're supposed to be focusing on the 5 times the -9. Now that multiplication, 5 times -9, those are different signs. That's a +5 and a -9. So opposite signs, so the answer should be negative. Leave the -2 alone, leave the plus alone. 5 times 9 is 45, but that result should be negative because they were opposite signs, 5 and -9. Now the only thing we have left is an addition. So addition is the SAK DSL rules. That's a negative, that's a negative. So it's SAK. Same add keep. 2 plus 45 is 47. And that should be a -47. And that's it. Okay, for B. We have a division, we have a multiplication, and an exponent. Don't just do this from left to right. Follow your order of operations. Do we have any parentheses? Actually, no, because this parentheses just has a -3 inside of it. There's nothing to do, so that doesn't count as a parentheses. But we do have an exponent. The exponent is this right here, the -3 squared, and that's in parentheses, so we are going to repeat that negative. So that's really -3 times -3. I'm just going to show that to the side, which ends up being +9. Same sign, so the answer is positive, SP. So this is 250 divided by 50 times 9. Oh, okay, we'll do the 50 times 9 first, which is 450, then 250 divided by 450. Nope, completely wrong. It doesn't say do all the multiplications and all the divisions. It says do the multiplications and divisions from left to right. So we have to do the 250 divided by the 50 first. And 250 divided by 50 is 5. They're both positive. You can say SP if you have to. Same positive, so +5. And 5 times 9 is also SP, same positive, and that's 45. And that is the correct answer. If you did 50 times 9, you'd get 450, then 250 divided by 450 would reduce to 25 over 45, which would reduce to 5 over 9. And again, that's wrong. It's not wrong because it's a fraction. It's wrong because it's wrong. All right, C. We got a subtraction, a division, and a multiplication. So there's no parentheses. Even though you see some parentheses, they don't count as parentheses. There's no exponents. So we're straight up to the multiplication divisions. Some people go, oh, 85 minus 56 is da-da-da-da-da. Nope. Don't do that first. Pay attention. Don't rush. And that's what most people are doing, is they're not paying attention and they're rushing. I'm not going to say I'm perfect. I've had my issues with not paying attention. and rushing. But fortunately, I always go back and make sure that things are sensible, so that the 1 to 5% of the time I make a mistake, we correct it. All right, so we got a division and a multiplication. We're supposed to do the division before the multiplication. So we're focusing on this part. Now, the subtraction, again, you can account for that minus being part of the 56 or not. It doesn't matter as long as if you don't account for it, you leave it, or if you do, then you bring it along. I'm going to do it this way. I'm just going to focus on this part. And I don't care if you bring the negative with it or not. If you do, then you'd be using the same, so the answer is positive. But I'm going to say they're different, so the answer is negative. So opposite and negative. So that gives me, and let me erase that circle. Again, I'm only focusing on the positive 56. So that gives me 85. Then the minus symbol. I'm bringing the minus symbol down. I didn't account for it. And then 56 divided by 14 is 4. But we had a positive 56 and we had a negative 14. So that counts as a negative 4. So that's 85 minus negative 4, and then times the negative 9. Now you could go ahead and fix up this double negative here and call that a positive. But I'm again going to wait, and I'm only going to focus on, I'll even switch colors this time. I'm going to focus on just this part. The negative 4 times the negative 9, that would be SP, same, so positive. So this is 85. I'm leaving the minus symbol in front, but then that 4 times that 9 gave us 36, and it'll be positive. 85 minus 36, if you want to rewrite, you can, is 85 plus negative 36. But it's a pretty normal subtraction, and you should get 15 minus 6 is 9, 7 minus 3 is 4, so 49. That's 49. Just gonna erase that. There we go. Come on, give me the drawing pen back. There we go. If you don't believe me that it works by just, oh, okay, I didn't use that negative, I left it out there. Let's try it a different way for fun. I'm gonna have to write kind of small. Maybe I'll use a little room over here. So alternatively, that says alt for alternatively. I'll do the whole thing in black. So that's 85. Let's say we did actually use the subtraction as a negative for the 56. So those would have the same signs. Same sign means positive for division. So that's now going to be 85, a plus symbol. And then 56 divided by 14, 2 negatives makes a positive, as we said, and that's a 4. And then times the negative 9. Then we do our multiplication, leave the 85 alone. We have our plus. 4 times negative 9 is negative 36 because they're opposite signs, so negative. And 85 plus negative 36 is literally the same thing we just saw. It's 49. So there is more than one way to skin some of these cats. But I didn't do things in a different order. I didn't do an addition before multiplication. It's just a matter of if I count as a subtraction as a negative instead. All right, D. We got 6.8 minus negative 3.2 in a bracket and then squared. Well, there's definitely a parentheses, but it's a bracket. So the bracket is counting as a parentheses. So we need to focus our attention inside of the bracket first. So we're just focusing on the 6.8 minus negative 3.2. Go back to red. All right, well, minus a negative, that's 6.8 plus 3.2. Let's leave the bracket. Let's leave the exponent. 6.8 plus 3.2. Line up your decimals. 8 and 2 is 10, carry the 1. 6, 3, and 1 is 10. So it looks like 100, but you gotta bring your decimal, so it's really down to 10. So that's 10. Now that's a positive, so I don't need the bracket anymore. If it was negative, I'd keep it. So that's just 10 squared. So our parentheses are done. The next thing we have is an exponent. 10 squared is 100 because it's 10 times 10. So the answer to D is 100. E, very similar problem. So we're going to focus our attention inside the bracket, inside the parentheses first, because that's what goes first. So that 3 is going to be the very last thing we do as an exponent. But we have that double negative again, so let's change that to bracket negative 3.6 plus 1.4, and then cube it. So inside the bracket again, we're focusing our attention inside here. Don't worry about the cube. This is an addition. That's the only thing to do, so we have to do it. And they're opposite signs. So that would be different, subtract, keep the sign of the larger. Negative 3.6 plus 1.4. Well, 3.6 minus 1.4 is going to be, what's that, 2.2. But we keep the sign of the larger. The 3.6 was larger. It's negative. So that's a negative 2.2, which means we do need to keep the bracket for the exponent of a 3. If I drop it, that would be a different process. Now, because it's an odd exponent, it would be the same answer, but that's just convenient and lucky. An even exponent, it would be different. So this is really negative 2.2 times negative 2.2 times negative 2.2. And let me give myself some room to show that. Here's my negative 2.2 cubed. So let's just account for the first pair, the negative 2.2 times the negative 2.2. Well, first of all, this whole thing is going to be negative because there's 1, 2, 3 negatives. That's odd, so a negative answer. So now I'm just going to focus on the 2.2 times 2.2 times 2.2. Well, 2.2 times 2.2. Remember, we're ignoring the decimals. It's just doing 22 times 22. 2 times 2 is 4. 2 times 2 is also 4. We're done with this one. Put a 0 in what I'm calling the ones place because we're ignoring the decimals. Then 22 times 2 is 44 again. And we add from right to left. That's 4, 8, 4. But there's one decimal in the top, one decimal in the bottom, meaning there should be 2 in the answer. So that's really 4.84. Then we got to take 4.84. I'm going to run out of room. Times 2.2. 4 times 2 is 8. 8 times 2 is 16. Carry your 1. 4 times 2 is 8 plus the 1 is 9. That's 968. We're done with the 2 and the 1s. So we put a 0 in the 1s. Then the same exact math, it's going to be 968 again. Let me just show that right here. So we got 968 plus 9,680. 8 plus 0 is 8. 6 plus 8 is 14. 1 plus 9 is 10, plus 6 is 16. 1 plus 9 is 10. So we get 10,648, but there were 2 decimals in the first one. There's 1 decimal in the second one, meaning there should be 3 in the answer. So it's 10.648. So negative 10.648 is our answer. Sorry, I was getting low on room, but you should still be capable of doing those decimal multiplications. Time, 15 minutes. We haven't done an absolute value in a bit. We'll do F. And then I'm going to start skipping around a little. So F. We got negative 57 plus negative 96 in absolute minus absolute negative 48. Absolute values count as parentheses, but the second one doesn't have anything to do inside of it, so it's only the first one that's really going to count as a parentheses. So we need to focus our attention on this first, the negative 57 plus the 96. Okay, well, those are addition of opposite numbers, so we're going to do DSL. Different, subtract, keep the sign of the larger. 16 minus 7 is 9. 8 minus 5 is 3, so that should be 39. So that's an absolute value of 39. 96 is bigger than 57, so that should be a positive 39. Then the minus absolute value of negative 48. And I'm going to change the color of this negative, this minus right here, to avoid confusion. So now we can take our absolute values. And when I take my absolute values, that negative's not inside of 1, so I leave it alone. But the absolute value of 39 is 39, and the absolute value of negative 48 is positive 48. Again, this subtraction was between two completely different absolute values, which is why that negative did not become a positive. 39 minus 48, we don't know how to do that normal subtraction, so we change it to adding a negative. That's 39 plus negative 48. DSL, different, subtract, keep the sign of the larger. 48 minus 39 is 9. The 48 is bigger than 39. 48 is negative. So negative 9 is our answer. I'm going to give you about 20 seconds to finish writing in case you're missing anything on that screen. Otherwise, you'll have to go back to the YouTube. And again, I want to mention, I'm kind of surprised with my viewer count on these YouTube videos. I'm really kind of terrified that a lot of people are not doing anything. And if you're not watching it, I'm talking to nobody. So those of you who are watching, thank you very much. You're only benefiting yourself. Okay. All right. 3, 2, 1, clear. Let's do this. What just happened? There we go. We're going to skip G. In case you want to know. So negative 36 divided by negative 16, the answer should end up being 2.25. So try that on your own, a positive 2.25. But we are going to do H. So 2 to the 4th minus 32 all over 9 minus 17. The tops and bottoms of fractions count as parentheses. There's an implied pair of parentheses around each of these, just in case you weren't aware. We treat the tops and bottom of fractions as their own entities, so they count as parentheses. But we just generally don't write them. So we're going to think about the top on its own, then we're going to think about the bottom on its own. So let's just focus on the top for now. The top. 2 to the 4th minus 32, there's an exponent of subtraction, so we got to do the exponent first. 2 to the 4th, that's 2 times 2 times 2 times 2, which you should be able to figure out is 16. So that's 16 minus 32 over 9 minus 17. We got 16 minus 32, which we don't know how to do that subtraction, so we change it to plus negative 32. Some of you may go ahead and change the subtraction to adding a negative in the bottom I think I said that already. Some of you may have already changed the subtraction to adding a negative in the bottom, and that's fine. But again, I just want to focus on the top initially. 16 plus negative 32, that's DSL, positive and negative. 32 minus 16 is 16, sign of the larger is negative. And then over 9 minus 17. So that's me just focusing on one air quote parentheses for now. Now let's focus on the bottom. So that's negative 16 over 9 plus negative 17, same thing we did to the top, which is negative 16 over. That's DSL once again. I told you this book loves DSL. 17 minus 9 is going to give us 8, but the largest negative, so that's a negative 8. And then 16 divided by 8 is 2. Those are the same sign, so the answer should be positive. So positive 2. Alternatively, you can work the top and the bottom in the same instance because they don't affect each other. So let's go back to this step right here where we had 16, sorry, this step. Where we had 16 minus 32 over 9 minus 17. Let's go ahead and change both of the subtractions to adding negatives. 16 plus negative 32 over 9 plus negative 17. The top, we know 16 plus negative 32 is negative 16. The bottom, 9 plus negative 17 is still negative 8, and that still gives us 2. So I don't care if you're doing the top and the bottom as separate entities or working them at the same time because they won't affect each other by working them at the same time. Alrighty, I. Let me go over here actually. So we got tops and bottoms. So I'm going to work the tops and bottoms in the same instance. So when I see an exponent, I'll clear exponents in top and bottom. When I see additions and subtractions, I'll clear top and bottom. Well, there's no parentheses that count as parentheses because these all just have single numbers inside of them. But we do have an exponent, so that's what we do first. Now, the exponent is applying to the negative 6 squared, not the minus in front of it. So we're just thinking what negative 6 times negative 6 is, which is positive 36 because they have the same sign, the answer is positive. The minus in front of it is not going to be brought along. So this is 59 minus negative 4 times negative 6 over 31 minus, again, this minus right here is this minus. In fact, let me show it in a different color for emphasis. So I'll change this to a blue, make that blue. And then the negative 6 squared in parentheses was our positive 36. All right, well, now we got to look for multiplications and divisions, and we have a multiplication in the top. We got this negative 4 times negative 6. I'm not going to focus on that negative I'm pointing at right now. This is just going to be brought over. So the 59, and again, I'll change the color. Let's make it green this time. So that minus I did not account for. The negative 4 times negative 6, that's the same sign, so the answer should be positive. 4 times 6 is 24. So that's a positive 24 with the subtraction that was in front of it originally. Over 31 minus 36. Let me go down to here now. We got subtractions, so let's change those to adding negatives. I know the top one you might feel like you don't have to, but I'm going to anyways, just for consistency. But you definitely want to change the bottom one. And this is just addition. The top and the bottom won't affect each other, so let's do them. 59 plus negative 24, different signs, opposite signs, so DSL. 59 minus 24 is what, 35? The 59 is larger, it's positive, so that's a positive 35. Doing 36 minus 31 is 5. The 36 is larger, so that should be a negative 5. This is one final step, that's a division. 5 goes into 35 7 times. That's a positive and a negative. They're different or opposite, so the answer should be negative. And we get negative 7 as our answer. I think we got time for one more, and let's do L. J is fun. 36 over 9. That answers 4. if you want to try it out on your own. I do need to clear my screen. Give you 10 seconds. All right. K is fun, but we're going to do L. All right, annotate. So again, PEMDAS, PEMDAS, PEMDAS with only 4 steps. 1, 2, 3, 4. There are no parentheses because there's nothing going on inside of these. Well, arguably you could say, oh, 15 and 48 would reduce. Let's hold on to that though. So we got an exponent, no parentheses, just the exponent. So that says we take the negative 3/4 times negative 3/4. Let me do that to the side. Negative 3/4 times negative 3/4. Negative times the negative is positive. 3 times 3 is 9. 4 times 4 is 16. So this gives us 9 over 16 minus 15 over 48 divided by 5 over 3. I'm going to drop the parentheses from the 15 over 48 because the negative is not inside of it, so it's irrelevant. And let's make sure that we see that that is a, where's my eraser? There we go. I just want to put that minus a little more in front so you don't think it's part of the fraction. So now we have a subtraction and a division. Well, multiplications and division come next, but we can't divide fractions. We have to multiply by the reciprocal. So this is 9 over 16 minus 15 over 48 times 3 over 5. So now we got a multiplication and a subtraction. Multiplication still comes before the subtraction. So we are focusing on this, which we can reduce. We got 15 and 5. Those would reduce with each other. 5 will go into 15 3 times and into 5 once. We got 3 and 48. Now, whichever one you want to take out, doesn't matter. Let's take the top one out. 3 goes into 3 once, and 3 would go into 48. What's that, 16 times? And then that's all we can reduce. So let me rewrite this since it got a little ugly. That's 9 over 16 minus 1 over 16 times 3 over 1. Let's do the multiplication now. 1 times 3 is 3. 16 times 1 is 16. So that's 9 over 16 minus 3 over 16. And this is where we would have to get an LCD normally, but, well, we already have it, 16 and 16. So we're just adding or subtracting the tops. If you need to do the rewrite of 9 over 16, you can, but I know most of us would skip it for this one because it feels natural, just doing 9 minus 3. 9 minus 3 is 6. So that's positive 6 over 16 because the larger is positive. But then 2 goes into both of those. 2 goes into 6 3 times. 2 goes into 16 8 times. So 3/8 is our answer. K is a little more challenging, which is why I did not do it. In the time we have, actually, no, it's not. You wouldn't have to get an LCD. Ignore me, but if you want to try K on your own, it's going to be very, very similar to L. The answer should ultimately be, give me a second to check myself. So cancel, that's 1 over 5, 2 over 5, that's negative 1 over 5, that's negative 3 over 5. So we didn't do M and N, but that's enough to cover the section. If you want to try M and N on your own, please remember that we can't multiply or divide mixed numbers. You have to convert to improper first. All your mixed numbers, just to make things as easy as possible, should probably be converted to improper fractions because we can only add and subtract mixed numbers. And you don't know if you're necessarily multiplying or adding or subtracting or dividing by the end of the problem because of the multiple steps. So that is 3.5 and 3.6. So that means that those will be due. What's today? Okay, so if you're in my Tuesday, Thursday class, they're going to be due on the 9th. If you're in my Monday, Wednesday class, they will be due on the 13th. So that puts us about just under halfway through this chapter. So we're moving at a pretty good pace, all things considered. Please make sure that you're keeping up with the homework at this same pace. Please make sure that you're going and taking the tests. I still have a ton of people that need to take test 2A and B. Remember that test 2 is going to stay split into 2 parts, but test 3 will end up being combined. That was not my decision. Again, I have no control over how these classes are run, quite honestly, outside of the actual lecture itself. So have a good day, and we'll see you on the internet next class. Where's my stop share button? There we go.